Hello everyone. I want to start off simple with a simple question. So, do you always know what or when to scale your applications? I will stand over here, then I can see some hands. So raise your hand if you always know this. Then if somebody raises his hand, I definitely want to talk to him, because I never know. And I've never talked to a single person that always knows. So, and this has always brought some scalability trap, basically meaning this is the reason why we even build microservices for simple systems. And that makes things complex. So that gives us a lot of uncertainties, and this brings a lot of uncertainties. So in this talk, I want to take you on a thought experiment, much like Schrödinger did. But then we try to defy the architectural uncertainty. And what I want to do is basically, I want to separate two things. We are engineers, we like to separate responsibilities. So I want to separate the development from the deployment. Meaning, the way we build an application has nothing to do with the way we are going to deploy it. So that's in essence what I want to do. First, there was already a short introduction of me. Has anyone watched Emily in Paris? Then you probably know I'm not him. Okay. With that, I'm also very tall, but that's also not very important. So my name is Peter, and you can probably hear from my accent, I'm kind of Dutch. But besides that, I'm also a co-founder of Masking Technology, and we are just a small consultancy company aiming at making other companies more cost efficient in their software development, and we do that by future-proofing them. And this is a bit of a part of future-proofing, I guess. I'm also a software architect, and I'm coming from a full-stack development background for, in a lot of technologies. So I've worked mainly with Java, C#, PHP, TypeScript, bit of Python, etc., etc. So I try to be technology agnostic. I think that's important. And also, I'm a hobby illustrator. But don't hire me, I'm not really good. You can see my work over there, it's very simple. But the thing with architecture is it's always boxes and lines, so that I can do. So let's look at the current state of how we look at evolution of an application. So obviously we don't want to start with microservices anymore. So a widely discussed pattern these days is if it's small and if it's simple, you start with a classic monolith. Once it becomes bigger or you add more teams or whatever, you go to a monolith or a modular monolith. There's a bit of a difference, but I won't bother you with the details here today. And if things go really big and complex, you go for microservices. And for the most part, I agree with this. But there's something that is kind of bothering me, that I think, okay, that's not really correct. I still, there are pictures taken, so wait till after that's done, okay. But to do that, we have to put them in perspective. So they're the same size, and I want to zoom in on their characteristics. So the first thing, the monolith, it's really good for, small projects, of course, for shared, because it has shared development, meaning every developer, every team even, is sharing the same code base. There are no boundaries or whatever, and it's just a single deployment, so you just deploy the whole app. So if you go to the next step, we have with the monolith, we have independent deployment, meaning so the modules can be developed independently and built independently and tested independently, but it's still deployed as a single unit, so a single deployment. And if we look at microservices, we have independent development and independent deployment. So, and if you look closely, then the monolith and the microservices are looking a bit the same. The only difference is the independent deployment. So basically, in my book, a monolith is a non-distributed version of microservices, simplifying things because you don't have things like network. Distributing things always make things complex. But if you look at the scalability, it has two types of scale, I guess. So if you look at the monolith and the monolith, it scales on an organizational level. So meaning if your app grows bigger, you probably are adding more features and adding more people to it to build it, more developers, more development teams. So that's more organizational. And the microservices, then you are starting to distribute things over multiple servers, so it becomes operational. So these are different types of scale. And these are basically different dimensions of scale. So if you look at the horizontal level, there's an organization. So, and if it scales, and if it becomes bigger, so you need more humans. This is simply put, of course. And if you look at the vertical of the vertical dimension, so you have the operation, and if that scales upwards, you simply need more machines. So if you look at these three architecture types, they kind of map like this. I kind of reserved this space for vibe coding, so small organization, but you just need a lot of machines. So I think this is, and of course, it's not all black and white, but I think this is best comparable with the pattern of evolution that we have seen. So, and if you want to scale, so we can scale our application, so for features and teams, we just can scale from a classic monolith to a modular monolith. But we can also scale, so for operation needs. So if your load is increasing, and you have a big app, because a monolith can also grow very large. And if you want to scale it, you probably only want to scale a single part of it. So you want to make it a service, and then you just want to scale that out on some cloud environment or something. So you basically you want to scale out for load, for fault tolerancy, for security, maybe for regions or some other reasons. But these are different concerns. And basically different dimensions for scale. So decoupling them, so we are basically decoupling these dimensions. So you can just build an application and you can make it grow organizationally, and by decoupling the operations part, it doesn't matter how you deploy it. So that's basically what I want to move towards, and what we have done and are building and are developing currently also in our organization. So I want to show you something. So the Schrödinger's app. We have a demo application that actually can be a monolith and microservices at the same time. And I think it is running. I don't know if the lights can be, is it okay? Nobody's blinded? Okay, well, I did this on purpose, of course, because I knew you have your after lunch dip, so now you're all awake again. So this kind of helps. So I want to introduce the application first, and then I want to dive into the code and how we actually architected and built this thing. So, but first things first, let me log in. I'm Major Banana. Captain Cookie is also here, he's on the front row. That's my business partner. So, and basically what it is, it's a social media platform, and it's just comic based. So you take a picture, you add a speech bubble, and then you share it and you can like it. Like this one. I like this because I made it myself, I don't know. So, and you have for you following. So basically, if you're on social media, it follows the same patterns as you see everywhere. So on Facebook, or now maybe not Facebook, but at least Instagram and these kinds of things. So you can explore things. And of course, the most important thing is to create one. I've summarized this talk. I've practiced really hard to do this, so I hope I won't fail. I think that's a great summary. So now we can move it. Yeah, I think that's pretty cool. And of course, I like it. And I can even react with a comment. And of course, I like this comment as well, because it's very cool. Thank you, thank you, thank you. So I think you have the basic idea. So you have a profile with the things you've made, and you can see them. And I think it's a logical thought that this will be a success, right? Everybody loves this. Everybody wants this. So this, at some point, this needs to scale. So moving back to our slide, so you can start sleeping again. The light is dimmed. So first, I want to look at the development part, because if you want to build an application that can be monolithic and microservices, that can be any normal application. So there are some rules of engagement to build such an application. So how we build it? Well, it's a monolith, basically. So it already has grown into a monolith. It can also be just a normal monolith, if you like. It doesn't have to be a monolith. But what we are doing, so because we want to chop it up in pieces, and the first one is we want to be able to slice vertically. So we used vertical sliced architecture, basically so feature slicing. But we also want to slice horizontally. So we also use the layering. I will show them in the next slide how this looks like. We used a procedural approach, because if you have a monolith and you start to split things, you want to translate things into some call to some other server. So and procedures or functions are easy to translate to a remote procedure call. So that simplifies things. And we want to have orchestrated workflows. So we want to do some routing. So if you have a function that calls other functions, so we orchestrate these things. And for all the side effects, like the notifications, for example. So if you create a comic, you want to notify people, that's a side effect. So that should not be in your workflow. So that will do choreographed, so by events, basically. So, and in the end, it looks like this. I use Lego blocks because I think that's a great way to show how it works. So here you see the layers. So we have basically a presentation layer, we have business logic, and we have persistence. We do a bit of domain-driven design. So we use the subdomains, and per subdomain we have features. So here you have the post. For example, the create post is one of the features. So we have something for rating, reaction, notification, etc. There are more you will see later. So, and we will be able to split this at any point we want. So we want to do vertical splits. So one of these features, we just want to split it off and just put it on the server. And basically, if only, for example, the reads from the database for the notifications is experiencing high load, we only want to take this block and put it on the server solely. And then once the load is over, we want to put it back in the monolith again. So that's the basic idea. So we want to slice it any way we want to make it more efficient. But that also means that we have to design our features to be able to do that. So if we look at how we have designed our features, of course they're stateless, otherwise they're not easy to distribute. They need to interact async, otherwise, well, you can't also distribute them. We have to work with immutable data, otherwise also things go wrong. And the features will also do the aggregations, all the data aggregations, so they will live in the features. And all the transactions, we use sagas, also live in the features. Because if you are going to scale an application, you basically are not only scaling your application, but you're also scaling the database. So there are also some constraints or some rules of engagement for the database. For example, if you also want to split and chop up your database, you can't have any relationship in your database, because otherwise if you pull out some table, things will hopelessly fail. So you can also use joins. So that's why we do the aggregations at feature level. And you can't have any transactions, so that's why we do the sagas in our code. So this way we can we can distribute the application and the database. So next up is the deployment part. So it's a social media platform. It will scale, we think, because it's going to be popular one day. We're not sure if we're going to use it actually, but it doesn't matter for the story right now. So we've created a wild distribution plan for the future. We think, okay, later if we need to scale, this is the way we want to do it. Of course, we need a backend for frontend, so the BFF pattern, so containing only the functions or the procedures required for gathering the data for the frontend. And we want to split this off eventually for security, so meaning the web client will talk to the BFF, and from there there will be a firewall protecting the rest of the services. So the BFF needs to do something with some business logic. So below the BFF, there's the business logic, and below the business logic, there are the reads and the writes. So this is basically, if you look at our layering, this is the presentation, the business logic, and the persistence. So I think that's a strong pattern there. And of course, we want to be this is for the load, of course. So we want to split up the reads and the writes, so we can take heavy loads if we like, or if we need it. And for the fault tolerance, we want to split up the notifications because it's not core business. So if the notification system crashes, we don't want to go that it takes the rest of the system with it. And it's only driven by events, so we can easily split it anyway. So this is basically the distribution plan we have now in mind, how we want to distribute our app. And with that, because if you separate your development from your deployment, what it enables you to do is basically to choose how you want to deploy it. What I will show and how the application is currently running is in development mode. So all these blocks, we call them segments. So we've just created, a distribution plan. And in that plan, you just segmentize your application, how you want to distribute it at the end. And it doesn't matter how you will deploy them. So you can combine them on a single server, on a single instance, like this, so how it's running now. And of course, in a single database, so everything together. And in production, we want to be able just to pull it apart and distribute it over multiple servers. So the front end is just talking to the BFF. From there, here's a firewall. You don't see it, but it's there. It's going to some gateway, and that will talk to the rest of the servers. And each server or service has its own data, like we basically do in microservices. So. And of course, that doesn't happen automatically. So besides building the app, you also need a tool that enables this, at least the dynamic splitting part. And we tried to find one online, but we couldn't find one. So we basically are building one ourselves. We call it GTAR. It's an abbreviation of just-in-time architecture. It's open source, it's free. So if you like to try it, be our guest. If you think this is not for me, also fine. And this is what I want to show in code. So we have 15 minutes or 60 minutes left. So that's okay. So I want to switch to the code. So here you can see. I will show this. Can I make this a bit bigger? Here you can see all the requests coming in. I will stop it for an instance and restart it. So then you can see, I don't know what it is. I've updated my Visual Studio Code, and now if I use my arrow up, I get this, but it repeats the command. It says npm run standalone. If anyone has an idea how to fix it, I'm open for it. So what it does, it starts a guitar instance with the whole application, and here you can see that it has created RPC procedures. So basically what guitar does, it creates your APIs automatically. And if you look closely, you can see that we here have a domain with a comic and a get by ID. So here you see that we have some domain code. This is our subdomain, and this is the feature. So here you can see that it just creates a RPC call per feature. And I want to show this in the code before we actually going to distribute it. And I'm going to rebuild it again. So let's explore the code. Can everybody read this? I have to stand here, otherwise I can't see you. Is this readable? Okay, great, thanks. So, as in any application, you basically have a source containing all the source. So we have a test, of course, for all the tests, which is basically a shadow of our application containing the same things, but then the tests. We have services. These are the guitar services. I will show them later. And we have the segments. As I said, so we create segments. If you look closely, we see 4, so we miss 1. Currently, Comify is small enough that we don't need a domain segment, because everything we currently do is for the front end. So everything is currently in the BFF. But for the next steps, we will create a domain segment as well. And I will open these later. So this is our deployment plan. And looking at the source, we have a few things. So we have assets, of course, so all the images, etc. We have the domain, so all the domain logic containing all the features. We have the integrations, so all the things we don't want to have in our domain. Basically the authentication, database things, event broker, etc., etc. And we have the web UI containing our React. Oh, what I didn't have told you, and that's maybe an important thing, is, so what's the stack in this case? So, as I said, I'm a Java developer, and most of the developers involved in this project are Java developers. So this is a TypeScript application. I think that's logical. And it's built on top of Node.js, so it runs on top of Node.js. We use Docker, of course. We use a Mongo database currently. We have Keycloak for the authentication. So I think these are the basic ingredients that we use. Here we also use Minio for the file storage. So it's basically the AWS object storage variant, but then the open version. So that's the stack. And I want to zoom in the more important stuff. I think that's the domain and how we have built the features. So let's go to the post first. So here you can see the features. So we have an aggregate feature that does the aggregation. So that goes on the BFF, of course. We have a create, but we have 2 types of creates. So a create with comic and a create with comment. And so we have all kinds of features, and I want to start with the get recomment aggregated. So that's basically the first list you get. So if I go back to Comify, if I go to the timeline, this for you list. So this is the recomment list. Now I can see you. So if I want to look into the room, I have to open Comify, then I can see you. It's a great tip. So this list is coming from this feature. And basically what it does, I have to close this, then I have a bit more space. And as I said, we have a procedural approach. So basically it's just a function, and it takes some parameters, and it's an async function, making it easy to distribute it eventually. So, and what it does, it takes a range, it validates it, then it gets the actual data from the database, which is a separate feature, because the aggregated features are the features placed on the BFF segment, and the actual data fetch features are placed on the reads segment. So it just awaits the data, and then it just maps the data with the aggregate function, and the aggregate function simply does fetching all related data. So our data objects are very simple. So we only store IDs. So in this case, the post, it has a relation for the creator. So who created this, and what's your relation with the creator? Do you follow him or do you not follow him or whatever? So I will check if you have rated the post or not. So we get either the comic or the comment, depending on what type of post it is. And we get the metrics data. So how many likes, how many reactions it has, etc. So, and then I return this as a simple JSON object or JavaScript object. So a plain JavaScript object, but it's typed. And here comes the immutability. So if we look at the immutability, we use the TypeScript types system for that, because that's the most efficient. So that means it's not immutable at runtime, but it is at development time, which is for now for us sufficient. So we just make a type with read-only fields, and then we know within the feature, if we are writing a feature, we can just modify the data. We have to copy it and then alter the data and pass it as a new object. So that's basically the trick that we are doing. So that's for the aggregate part. If we go to the data part, that's basically just a simple query. So we just, it's multi-tenant, by the way. And we just fetch all the data for a tenant for the creator. So we call our users creators. So the current user, we look at a parent ID, because posts can have parents. And of course, if it's deleted or not. And then we just fetch the records and it goes back. So that means that this one is running on the reads segment, and the aggregated one is running at the BFF segment. And I will show you how that works. Let's see, where are my segments? So if I go to my segment file, it's currently a big file. We still need we need to optimize this. We will do that eventually, I think. It's still a concept. So what we have, the BFF contains the authentication features. It contains some creator features, like the aggregate and the get by ID aggregated. And for the post, that's where we are looking at. So here's the aggregate, but it's private, meaning you can only access it from this segment. So that means other segments cannot access the aggregate. And if you look at the create, this one is private because we are creating one with comic. And if we look at the get recommended aggregated, that is here, and it's public because our web client needs to access it. And this way we just list all the features that belong to that segment, and that's how we set up our plan. So it's the same for the reads. So here we should also see for the posts. So the get recommended is here, and it's protected, meaning that it can only be accessed from another GTAR node or GTAR instance. So the web client can't access it. That is basically what it means. So it's not open for everyone. So that is how we map features to the segments. So we've already seen the reads. So I want to show you the writes real quick, or how we build our sagas, basically. So if we go to the create, what we have seen is the create with comic. That's this one. And in this case, it just first creates a comic, and then it creates the post with the comic ID, and it doesn't have a comment ID. That was the simplest way we could think of to build this. And what this does, this creates, it basically leverages a simple try and catch block for building a Saga. So what it tries to do, it creates the data, it validates the data, it inserts the data, and then it saves the post ID, and then it tries to publish an event. And only if this fails, then we know that we already have created the post. So it returns into an error. And what we do, and that is what the Saga does, we see, okay, we have already successfully completed one of the steps that needs to be made undone. So in this case, a step fails. We have already a post, so we erase the post. So everything either completes together, either results in a success together or fails together. And that's basically what a Saga does. So this is not very hard, this way, to build a Saga in code. So to create some transactional system. So, and those are the two things I think are the most important. So now, how much time I have left? 4 minutes. Okay, I'm right on time. I will open the terminal. And now I have to do a lot of things, because scalable systems is fun, but you still need to start a lot of services. So here we go. So first we need to start a repository. So we go in production mode now. So we need a repository because we have a web client and a repository acts as a web server or a web server. So that one is running. We need a gateway for the routing for all the requests. We need the BFF to run, containing only the BFF features. And this is the list, what it has created and what it exposes. We need a proxy for the web client, because it needs a combination of the BFF and the repository on a single address. So we have split off the notification, so it's running in its own instance, and here you can see that it only picks the notification create, get by post ID, etc., etc. So not the BFF stuff, but only the things it's responsible for. So now we can separate the reads, and we can run the writes. And if everything still works, we should be able to click this button without any trouble. Okay, it's still working. And if we go back and we will look at the BFF, then you see that it run a lot of requests. So it got the login URL, so it needed to log in again, because my standalone service was put down, so all the authentications and all the sessions were gone, so it needed to build up a new session. And then it could get all the data. And if we look at the notification, that should be empty, so it has done nothing. I will clear it to show that it will get the right request. So the reads, was quite busy, because it to fetch all the aggregated data. So it got quite some requests. I will clear this as well. And the writes, well, these are only the features, and it hasn't written anything yet. So that means if I go back and I will love my own post again, then we should see that it has updated two things. So it has written the rating, so it has created the rating, and it has updated the metrics for the post. So that means the likes is +1. And the reads has only done a few things, and the notification should be still be. Oh, it has of course created a notification because it received an event, because I liked something. And if I go back and I go to notifications, then go back to notifications, then we should see that it has run the request get recent. So that means that every part of the application is now running in its own instance of guitar. So we basically separated and distributed the application by only configuration. So basically saying that our application, Comify, is from a development perspective in any architectural state at the same time. And so its true form now is only revealed at deployment. And with that, the time is over. So I want to thank you. And
all right.
If you want to know more, you can always find me at the conference. Of course, I will be here the whole day. My business partner, Bas, is also here. You can I recognize him on his guitar shirt. We write also about this topic, so you can look at our website. So if there are any questions, just let us know.
Exactly. And I was going to say, like, you look just like that photo. I can relate. So, Peter, thank you so much for your presentation.
You're welcome.
Yeah, Peter will be around if you have any questions. So, everyone, I'll see you around in 5 to 6 minutes for Ferris Talk. See you in a bit. Once again, give it up for Peter.